In the previous video, we talked about solving quadratic equations by factoring. However, not all equations are factorable. So when we can't factor, we use the quadratic formula to solve quadratic equations. Now the quadratic formula will solve any quadratic equation, whether it's factorable or not. So the factoring method only works sometimes. With the quadratic formula, this always works. Okay, so this is the quadratic formula. For that, we need all the terms to be on one side, the other side to be equal to 0. So this is an example from the previous video. We previously used this, solved this by factoring, but now we're going to use a quadratic formula. Okay, so step 1, let's move all the terms. So subtract the 27x, add the 12 to one side. Other side is equal to 0. Just like with factoring, we always take out the greatest common factor first. So these have a common factor of 3. Take that out. So we're left with 5x squared minus 9x plus 4 equal to 0. And then we divide everything by 3. So we get 5x to the second power plus 9x plus 4, and that is equal to 0. Okay, then we identify our a, b, and c values. So the value of a is 5. A is the coefficient of the x squared. The value of b is negative 9, the coefficient of the x. And c is the constant. So we have 5, we have negative 9, and we have positive 4. So now let's go ahead and plug these in to the quadratic formula, which is up there. So the solutions of x are going to be negative b. So we have negative. Every time you replace a variable with a number, always use parentheses. So b is negative 9, which means we get negative negative 9. We get a double negative, one from the formula, one because the actual b value is also negative. Then we have plus or minus the square root of b squared. So b is negative 9. So it's negative 9 squared minus 4 times a, which is 5, times c, which is 4, and then all of that is going to be divided by 2 times a, which is 5. Okay, let's simplify this. Got negative negative 9, that's a positive 9. Negative 9 to the second power is 81, that's 9 times 9. Negative 4 times 5 is negative 20. Negative 20 times 4 is negative 80, so we got 81 minus 80, all divided by 2 times 5, which is 10. Let's keep simplifying. 81 minus 80 is 1, so we have a radical 1 all over 10. Square root of 1 is 1, so we get x equals to 9 plus or minus 1 all over 10. Now here's what the plus or minus means. It means that x could be 9 plus 1 over 10, or x could be 9 minus 1 over 10. So 9 plus 1 is 10 over 10, which is 1. 9 minus 1 is 8 over 10, which is 4/5. So our solutions are x equals 1 and x equals to 4/5. Now notice that in the previous slide, when we solved this by factoring, we got the exact same solution, 4/5 and 1. Okay, but the quadratic formula works all the time. Here's another example. I'm sorry, should have been a 2z to the second power. And this one we will do in class. But first, let's just start the problem. GCF, there is none. So no GCF. The value of A is 2. The value of B is negative 3. And the value of C is negative 9. So if you want to try this, you can. Otherwise, we'll also go over this in class. Now, here's how we find the x-intercepts of quadratic functions. To find the x-intercept, we set f of x, which is the same thing as y, equal to 0, and solve for x. To find the y-intercept, we set the x equal to 0, and then you simplify. So let's find the x and y-intercept of the following function. We got the x-intercept. And the rule for the x-intercept is always the same, whether it's a linear function or a quadratic function. you always set y equal to 0. And then for the y-intercept, you set x equal to 0. Now in this case, f of x, this is equal to y. So to find the x-intercept, we are going to set this equal to 0, and we have negative x squared plus x plus 20. When you have a quadratic equation you want to solve, you can use a quadratic formula or you can factor. Now factoring is always easier, so let's try to factor it first. But before we can factor, the x squared has to be positive. So here's what we're going to do. We're going to divide everything by -1. And if you divide the right side, we got to divide the left side by -1 as well. But luckily, 0 divided by -1 is going to be 0. Negative divided by negative gives you a positive x squared. That's what we want. X divided by -1 is negative x. 20 divided by -1 is negative 20. So we can always divide everything by -1 if it's an equation in order to make the x squared positive. Now we got to factor this. There's no GCF, so we make our x factor. We put a, which is 1, times -20 on top. We put the -1 on the bottom. We want to find two numbers that multiply to be -20, add up to be -1. That's -5 and 4. We ignore the square, so we just put the x on top. These can't be reduced, so the x's fall over. So we're going to get x minus 5 times x plus 4. By the zero product property, we get x equals to 5 and x equals to -4. But because these are intercepts, remember, these aren't just solutions, these are x-intercepts. To get that, we set f of x or y, the whole thing equal to 0. So we have to write these as ordered pairs. Our x-intercepts are going to be 5, 0 and -4, 0. For the y-intercept, we set the x value equal to 0. So we basically want to figure out what is f of 0 equal to. Our x value, or our input, is equal to 0. So we're going to get -0 squared plus 0 plus 20. Anything 0 to the second power is 0, 0 is 0, so we're going to get f of 0 is equal to 20, so our y-intercept is going to be 0, 20. Okay, and that's how we find intercepts. Example, a person's systolic blood pressure, which is measured in millimeters of mercury, depends on a person's age in years. The equation P equals to 0.005 y squared minus 0.01 y plus 118 gives a person's blood pressure P at age y years. Find the systolic pressure to the nearest tenth of a millimeter for a person age 42 years. So here's our equation. Okay, our equation is this. It's P equals to 0.005 y squared minus 0.01 y plus 118. And remember, we got to figure out, we got to always define the variables. So y is years and P is a blood pressure. So what are we looking for? We're looking for P. And what are we given? We're given that the age is 42. So we're going to say the blood pressure is 0.005 times 42 squared minus 0.01 times 42 plus 118. Now at this point, you would put this in a calculator. You could use whatever calculator you want to. The one I'm going to recommend for you guys, if you don't have a scientific calculator that you can just put all of this at the same time, then we're going to use a calculator on this website, desmos.com. And we're going to be using this website quite a lot, so get familiar with it. The one thing you don't want to do is do not use cell phones as calculators, because that just takes too long, it's too complicated. So if you don't have a scientific calculator, or even if you do, Desmos is a great website. So here's what we're going to do. We're going to go to the browser, and we're going to go to desmos.com. Okay, and then just click on Start Graphing. Even though it says graphing, you can also use this as a calculator. So let's put in our function. We have 0.005 times 42. Now your exponent key is right there. So it's going to be 42 squared minus 0.01 times 42 plus 118. So the blood pressure is going to be 126.4. So let's go back over here, and we're going to say that the blood pressure is equal to 126.4. Now the second part says, if a person's systolic blood pressure is 125.6, what is their age? So now remember, this is the p-value. So where is that going to go? In this equation, it's going to go right there. So we're going to say 125.6 equals to 0.005y squared minus 0.01y plus 118. Now this is a quadratic equation. So what do? To solve any quadratic equation, we have to move everything to one side, which means we are going to subtract 125.6 to both sides. So we're going to get 0 equals to 0.005y squared minus 0.01y minus 7.6. Now at this point, we could use a quadratic formula, but that takes too long. And the objective of this class is not to learn the quadratic formula, but rather to interpret the solutions of this equation. So here's what we're going to do. From now on, to solve quadratic equations, instead of using quadratic formula, we're going to go back to Desmos. Okay, so let's go back to Desmos, and we're going to put in our equation. So our equation is this. It's P equals to 0.005. Now here's the thing. Here's the only thing you got to worry about. We cannot use y as a variable. So even though the problem says y, we're going to replace the y with x. Okay, so we have 0.005x squared minus 0.01x. I think y is the only variable you can't use, plus 118. Okay, so we, it was minus 7.6. So we're putting in this function right there, 0.005y squared minus 0.01 minus 7.6. And then, once you have that, you want to zoom out. When you zoom out, your solutions are going to be where the graph crosses the x-axis. So there are two points where the graph crosses the x-axis, negative 38 and positive 40. Now, a person's age can't be negative. A person can't be negative 38 years old. So the only possible solution is going to be this one, which is x equal to 40. So once again, graph this, and the solution is always going to be where the graph crosses the x-axis. So the solution to this equation is going to be x equals to 40, since a person cannot be negative 38 years old. Okay, so we're going to go back here, and we're going to say that the age of the person, y, is 40 years. Okay. Now, the next few examples we are going to go over in class. So don't worry about those. If you think you have any questions up to this point on the videos, please come prepared. But the rest of these examples we're going to cover in class.